Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. We are doing polymers and our topic for today is condensation polymers. These polymers are formed as a result of condensation of monomeric units which are different and have also some specific functional groups. Thus, they are copolymers in nature. The two monomeric units are different. So, first category of polymers that we will do are polyesters. So in organic chemistry we have studied that when a carboxylic acid combines with an alcohol, the small water molecule is eliminated and the two join to each other and form an ester. So the linkage point is C double bond O single bond O, COO group. So this is ester. If one of the two participating molecules has two functional groups, the esterification is completed in two steps. For example, in the first step, now ethylene glycol has two OH groups. In the first step, one OH of ethylene glycol will combine with the carboxylic acid group of acetic acid. Water will be eliminated and the two will join. So we get CH3COO CH2OH. This is monoester. In the second step, the remaining OH will also combine with the COH of acetic acid to form linkage from both the ends and a diester is formed. And if both the participating molecules are bifunctional, then the reaction is called condensation and it is completed in a series of steps with elimination of small molecules. For example, in this case, water. So the process is known as condensation polymerization. So important polyesters where the linkage is ester linkage are Terraline and glyptal. In case of Terraline, the monomers are ethylene glycol, of course, and terephthalic acid. Means CO2-COH groups are present on para positions of the benzene ring. So the OH of ethylene glycol and COOH of terephthalic acid will combine to eliminate water and they will join from this end, so a monoester is formed. In the next step, this molecule, bigger molecule, will combine with another molecule of ethylene glycol so that ethylene glycol is attached on the second end as well. Then again this polymer will combine with terephthalic acid to form terephthalic acid to attach terephthalic acid on the other end, and the process is repeated again and again, ethylene glycol, then terephthalic acid, then ethylene glycol to form a big polymer of high molecular mass having this unit as repeating unit. Ethylene glycol, phthalate, terephthalate, then ethylene glycol, then again repeated. So the polymer is called Terraline. Terry comes from terephthalic acid and lean comes from ethylene glycol. This polymer is also called DECRA. The Terraline is highly resistant to action of chemical and biological agents. Its fibers are quite strong and durable. It can also be blended with wool or cotton. So when it is blended with wool, it will be called terrywool. When it is blended with cotton, it is called terrycot. So we obtain fabrics of desired composition. The Terraline is used in manufacture of variety of cloths such as terrycot, a blended fiber of Terraline and cotton; terrywool, a blended fiber of Terraline and wool; and terrysilk, a blended fiber of Terraline and silk. So as a result of blending with other yarns, we get variety of cloths. Then it is also used for preparing magnetic recording tapes, conveyor belts, aprons for industrial workers, etc. Now here one of the monomeric unit was terephthalic acid. In case of glyptal, the terephthalic acid is replaced with phthalic acid, means the two COH groups are present at ortho position rather than para position. So ethylene glycol with phthalic acid combines to form a dimer, and it will again combine with ethylene glycol, which will again combine with phthalic acid to have this repeating unit n times, and the polymer formed as a result is called glyptal. Glyptal is a network cross-linked polymer. When dissolved in suitable organic solvent, the solution formed upon evaporation leaves a tough and non-flexible film, and this glyptal is used in manufacture of paints and lacquers, for making building materials such as asbestos and cement. Then the next category of polymers, condensation polymers, is polyamides. Here the repeating unit is CONH, amide linkage. In polyesters it was COO, here it is CONH. These condensation polymers have an amide linkage present in the monomeric units. For example, nylon 6,6 is a polymer of hexamethylene diamine, 6 methylene groups and 2 amine groups, and adipic acid, 4 methylene groups and 2 COH groups. These will combine stepwise to form a polymer nylon 6,6. Here CONH is the repeating unit. Where nylon 6,6 has this name because the two monomers has 6 carbon atoms each. There is a strong intermediate hydrogen bonding present in the constituent chain of nylon 6,6. As a result, the fibers made from it are quite hard, crystalline, and have high tensile strength. These are resistant to abrasion. Nylon 6,6 is used in making bristles of toothbrushes, in manufacture of sheets, cords and climbing ropes, for preparing socks and sweaters when blended with wool. Now, nylon 6 is also a polyamide, but it is polymerized product of caprolactam, which is obtained from cyclohexane as a result of series of reaction. Cyclohexane will be oxidized to form cyclohexanone. When it is reacted with hydroxylamine, the O and H2 will combine to form water. Water will be eliminated and NOH group gets attached, so cyclohexanone oxime is formed. This, on reacting with sulfuric acid, undergoes Beckmann's rearrangement, where the NH comes here and double bond O here. So a compound is formed with 7-membered ring, 6 carbons and 7th NH, and this is cyclic with double bond O. It is called caprolactam. So caprolactam, when heated with water to about 533 to 543 Kelvin, will undergo hydrolysis. So it breaks from here, water will be added here, OH here and H here, to form a NH2, then 5 carbons, then COOH. So this is a monomer. This, when polymerized on heating, will polymerize to have this as repeating unit, CONH as repeating unit, and the product polymer so formed is called nylon 6. So when caprolactam is hydrolyzed and the monomer is polymerized, nylon 6 is formed. Whereas in nylon 6,6 we had 2 different monomers. Here it is only 1 monomeric unit. Though it is called nylon 6 since the monomer unit has 6 carbon atoms, and it is also interlinked by intermolecular hydrogen bonding. So it is hard and crystalline in nature. It finds application in manufacture of fabrics, ropes, tire cords, etc. In German, nylon 6 is popular with another name, Polon L. Quite recently, nylon 11 with 11 carbon atoms in the repeating unit and nylon 12 with 12 carbon atoms in the repeating unit have also been formed. And nylon 11 is formed by polymerization of omega amino undecanoic acid, and nylon 12 is obtained from dodecane lactam by hydrolytic polymerization. Then we have nylon 2, nylon 6, another synthetic biopolymer. It is biodegradable in nature, and the monomer units are glycine and amino caporic acid having 6 carbon atoms, and 2 in glycine. Glycine is COOH, then we have CH2 and NH2. This is glycine having 2 carbon atoms. This has 6, so the name is nylon 2, nylon 6. Next is formaldehyde resins. Resins are non-volatile solids or semi-solids which are obtained directly from certain plants and can also be synthesized as a result of polymerization in the resins. One of the constituents is formaldehyde, so they are called formaldehyde resins. These are thermosetting in nature. We have 3 formaldehyde resins: phenol formaldehyde, then melamine formaldehyde, and urea formaldehyde. So let us do phenol formaldehyde resin. Phenol and formaldehyde, when they combine with each other, will undergo condensation. The ortho or para hydrogen gets added to the doubly bonded oxygen. So H comes here, one bond is broken. So H gets attached here and CH2 will get attached to this position. So we get a methyl alcohol attached to phenol at ortho or para position. When attached to ortho position, it's called ortho hydroxy methyl phenol and ortho hydroxy methyl phenol and para hydroxy methyl phenol. When ortho hydroxy methyl phenols they polymerize, they condense, the OH of one and H of other combines to form water, and this gets attached on this position. A linear polymer is formed which is called novolate. And if the ortho and para, they combine with each other, a cross-linked polymer is formed which is called bakelite. Now bakelite is the cross-linked thermosetting polymer. Low degree of polymerization will give soft bakelite. High degree will give hard bakelites. Soft bakelites are used for making glue for binding laminated wooden planks, varnishes and lacquers, and hard bakelites are used in manufacture of combs, fountain pens, formica tabletops, electrical goods, etc. Then second formaldehyde resin is melamine formaldehyde, where formaldehyde and melamine will polymerize. So melamine, the H of melamine, this compound will get attached to formaldehyde. The electrons move here, H moves here, so OH is formed, and NH will combine with CH2. So this is NH-CH2OH. Now this is a step-proof polymerization. First one formaldehyde adds on this side, then another can be attached on this side, then another on this side, and when it undergoes polymerization from all the directions, cross links can be formed in all directions, and a melamine polymer is formed. This melamine polymer can be used in making crockery. It's very hard and tough, and it's used in making crockery. The cups and plates made from it are unbreakable. Then third polymer is urea formaldehyde. So urea and formaldehyde, when combined, will form this CH2OH linkage on one side of NH, and then secondly another side will also get converted to CH2OH conversion. Now this will act as a monomer, and when it's polymerized, it forms linkages in different directions to form a cross-linked polymer known as urea formaldehyde resin. So it's used in laminated sheets and also in plastic molds. Polyurethane is a polymer compound of organic monomers, polyisocyanate and ethylene glycol, joined to each other by linkage known as urethane linkage. So this electrons move here, and the H will come to oxygen and O will come to carbon. So it gets linked in this manner. So this is CONH, C6H5, CH2, C6H4, then we have NH, then we have C double bond OO, CH2, CH2. Then again this unit will get combined. So on repetition, a polyurethane linkage results, this is the repeating unit, and the polymer formed is called polyurethane. It's a thermosetting polymer and is used in the manufacture of rigid foam insulation panels, durable elastomeric wheels and tires such as roller coaster, escalator, skaterboard wheels. Hard plastic parts of electronic devices are all made up of this polyurethane. Now, we have done addition polymers, we have done condensation polymers. The difference between the two is the monomer units are unsaturated in nature in addition polymerization, and they have at least one double or triple bond. Whereas in condensation polymerization, we have different functional groups which combine, resulting in elimination of molecule, small molecule, and linkage. It is a free radical or ionic mechanism. The intermediate is free radical or cation or anionic in nature. Here no intermediates are formed. It is a chain growth procedure, it's a step growth procedure. Initiators are needed to bring about polymerization. No initiators are needed. Polymers are mostly exact multiples of monomers. In this case, the polymers are not exact multiples of the monomers because molecules like water, HCl, ammonia are lost and the linkage form is changed. So polymers are not exact multiples of monomers. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.